Okay, it's 2:45. I'm trying to respect your time. Okay, so because of that, I will read so I don't get lost in my thoughts. Welcome, everyone. My name is Bruno Theodosio, as you probably already know at this point. I'm an assistant professor of economics here at University of Tulsa. It's a great honor to moderate this panel today. I see friends both on the panel and in the audience, and I believe that we all, as a community of heterodox economists, will gain valuable insights from this discussion. One of the defining features of heterodox economics is its openness to diverse approaches, theories, and methods. This session is titled Probabilistic Political Economy because of its unique combination of methods from information theory with classical political economic topics. The term probabilistic signals the adoption of probabilism in economics. Determinism in economics begins with idealized theoretical constructs such as uniform profit rates or single prices for commodities, treating real-world variability as noise added to approximate these ideal states. It views statistical spreads around deterministic truths as secondary, something imposed later to refine deterministic models. In contrast, probabilism rejects the notion of idealized point states altogether, treating economic variables like prices and profit rates as inherently uncertain and focusing on their probability distributions. Probabilism embraces variability and distributions from the outset. As Paulo puts, and I'm going to present them in a second, as Paulo puts, the regularities of economic systems are social, their expressions are statistical. And as Ellis puts, posterior distributions are rational expressions of beliefs. Classical political economy was an early adopter of probabilism. Smith's idea of the social division of labor emerging from labor movement between sectors seeking higher profitability and Marx's insights on capitalist competition demonstrate how classical economists recognize the distributions, uncertainty, and contradictions as fundamental features of economic reality. This rich intellectual heritage grounds probabilistic approach in the historical and institutional dynamics of capitalism. We view the capitalist system as a complex, dynamic structure where individuals' interactions, shaped by institutions, produce measurable and recurrent social outcomes. It creates spontaneous order from decentralized and uncoordinated behavior of workers and capitalists, generating economic variables that can be characterized in terms of central tendencies and fluctuations around those tendencies. Equilibrium, in this context, is not a fixed point, but rather a stationary, sometimes empirically verifiable probability distribution. One strength of this approach is that it offers a new way to think about the relationship between micro and macro. We can go from knowledge we have at the micro level and think of macroeconomic outcomes as the combinatorially dominant state consistent with the knowledge. We can go from the knowledge we have at the social level and think of how it constrains the possible outcomes of different individuals. The macro is not just the micro many times over. By rejecting oversimplified models and offering new foundations for empirical work, probabilistic political economy offers a comprehensive framework for understanding and transforming economic realities. As we will see today, the field employs a variety of methods and techniques and is by no means monolithic. Tools drawn from statistical mechanics, information theory, Bayesian probability, and complexity theory enrich its scope. Probabilistic political economy advances heterodox economics by developing theoretical models and analyzing empirical phenomena, including profits, wages and money distribution, technology concentration, inequality, the division of labor, and more. For today's discussion, we have an outstanding panel of scholars. I'm going to present all of them at once. So we have Paulo dos Santos, Professor of Economics at the New School, Ellis Scharfenaker, Associate Professor of Economics at the University of Utah, Doguhan Sundal, Assistant Professor of Economics at California State, and Bruno Theodosio, assistant professor here at the University of Tulsa. So, Paulo, the floor is yours.
Okay, let's see. I'm struggling with my voice. Can you hear me? This will be difficult.
Try to stay closer.
The subject matter is difficult, and obviously I barely have a voice. Hopefully we'll come back. Okay, hi. I should write shorter titles if I'm gonna have my voice problem. That's the title. Okay, can I... Okay, so the paper draws from a wider body of work. Actually, thank you. Draws from a wider body of work where I'm trying to apply concepts and instruments from information theory to political economy. And divide the talk into 4 parts. I'll give the game away in the first part because it's not a mystery novel. I'll say a couple of things by way of the origins of the problem with conventional statistics. And then I'll contrast the 2 paths that can be taken to statistical analysis. One based on the conventional notion of covariance, and the other one based on the notion of information and intersections of information. Okay, here we go. The main point I would like you to take away from today's talk, beyond the hoarseness, is that the philosophical problems and controversies in probability theory, the debates about Bayesian versus frequentist statistics are very much of concern to heterodox economics. And that is because conventional treatments of statistical analysis actually introduce explanatory and discursive biases that we ought to reject. Broadly, 2-fold biases. One, it tends to misrepresent what it is that we get from statistical inference. It presents it as statements of fact, objective truth, as opposed to the understanding that what statistical inference gives us are statements of rational belief given well-stated priors. Something far weaker, something far more nuanced, something far more contestable. The second issue, of course, is that there are, a point that I've been emphasizing for a while, deep individualist prejudices that are baked into the very foundation of conventional statistical analysis. And they are baked so deep that they have shaped even what we accept as empirical explanation. So that what we expect when we demand explanations is individualist even before we think about it. We ought to be able to reject that. Information theory helps us reject that. Okay? So in the paper, I take the common situation where we have a system with n individuals, and we're interested in a particular variable, y, an outcome, could be income, could be life expectancy, anything of interest across the individuals. And then we can observe some covariates, k of them. And we'd like to learn about the processes that generate y from what we can observe. Very run-of-the-mill statistical problem. And the point that the paper makes is that with a few conceptual developments and a couple of formal results, we can get from information theory what I've started to call a meta-theoretical approach to the generative associations between y and the covariates. It gives us an approach that generalized linear regression analysis in a variety of really important ways. It steers analysis to explanations that are social, not individualist, that are generative, not representational, that are multivariate and not bivariate, and explanations that hold true regardless of the distributional forms. Regression models will appear as special cases of these more general truths. So it's not that regression models are wrong, It's just that they are the particular expression of a deeper underlying truth when particular distributional forms happen to be in place. People with me? And that's very important. For many reasons. One of them is that it means that the framework that the paper develops can also be used to test the boundaries of applicability of regression analysis in a joined-up systematic way, without the ad hoceries that we normally appeal to after the fact, trying to figure out if the assumptions that we started with were appropriate or not. It's really an epistemologically curious approach that we have settled on in conventional analysis. Okay, let's talk about the origins of this briefly. It turns out that eugenicist thought has profoundly shaped the development of conventional statistical analysis. Galton, Pearson, and Fisher were all eugenicists and believed that statistical theory was going to become the vehicle that would enable them to pronounce eugenicist truths as scientific fact. Audrey Clayton, in a really good book he put out recently called Bernoulli's Fallacy, makes the point that part of the key reason why Bayesian inference and Bayesian understanding of probability has been marginalized in statistics is because these three eugenicists wanted statistical analysis to appear as capable of producing statements of objective fact. And the very diligent approach to what we know and what we don't know, what we may or may not infer of the Bayesian approach threatened that. I think that's a very interesting point. I'm emphasizing a related point, but slightly different, that there's an additional eugenicist prejudice that's baked into the very base of the cake of conventional analysis. We use abstractions in conventional analysis where individual outcomes are framed not as a result of social interaction, not as a result of specified generative processes, but as expressions of inherent individual characteristics. And this is done in a two-part representational abstraction that we don't even think about. We just use it so much, we don't even problematize it. Our statistical models actually make no statements about interactions or interdependencies across individuals, right? You just think, okay, your outcome, Y, is the result of two steps. The first step is, well, tell me what your covariates are, V. That will give me the expected value of your Y. And then you have an irreducibly idiosyncratic shock on top of that, and that's it. Your characteristics set your mean, and then chance sets your value from there. That could be true in many cases, but that's a very specific abstraction. People with me? And it's not generative. There's nothing being said here about interactions, about processes. The data that we analyze is cast as the outcome of independent processes where each individual, up to what we observe, faced the same process as the aggregate distribution. It's a very peculiar choice in social analysis, where from the get-go you proclaim, I know everything. And within that everything, everybody's the same. Whereas social analysis ought to start from a recognition of how deep our ignorance is. And given that ignorance, we absolutely must not suppose that beyond what we know, people are the same. In fact, we should expect the exact opposite. Beyond what we know, we should expect social difference. People with me? But that's not what we get from conventional approaches. Is this making some sense? Can you hear me? Okay, how much time do I have? Oh, this is great. I can go on. Okay. Now, this is all very important because actual formal social inquiry is hard. And it's harder than most people think. If you're trained in physics and you start thinking about social inquiry for the first time, your first reaction is, crap, this is impossible. First, socioeconomic systems are complex Everybody says this, that these days, so it's not terribly exciting. But the kind of complexity that we have is different. It's not your grandmother's complexity. Social systems have members that exhibit what philosophers call relational interiority. What does that mean? That in the very nature of what social individuals are, we see reflections of their relations with others. The relational aspect of our interactions actually shape what we are, so that the individual becomes rather problematic as a departure point for analysis, because what the individual, him or herself, is actually part of the interactions that we're trying to explain. That makes things really, really hard. So not only are the relations dynamic and nonlinear and complex, but everything's changing. It's like Hegel was right. Making matters even worse, the possibilities for observation that we have are terrible. If we're lucky, we get partial data. In fact, we don't know what the full array of data that would be necessary to explain is. We don't. And even when we do observe, we observe things at frequencies of time that are much lower than the frequencies at which people interact. So you're dealing with partial low-frequency data and large-dimensional, really complicated nonlinear systems. There's no way in hell you can square that. People with me? Certainly not with detailed microkinetic specifications. General equilibrium analysis, the individualism the representational individualism of regression analysis, they're all simplifications and abstractions. And you can understand people going for those, fine. And sometimes that's all you can do. I'll get back to that towards the end. But we must absolutely be clear that we're doing a great deal of violence to the reality when we do so, and be ready to recognize where the boundaries are of what we conclude if we take that step. And what the paper is trying to do is to set the boat going on a different way of going about statistical inference that does not commit these errors, okay? So I'll try and explain that. There's some math. I have no voice. It's after lunch. Wish me luck. Okay. So, let's see. Whoa, okay. There are two paths that we can take in statistical analysis. The conventional path starts with the use of covariance measures, and the other one, informational measures. I mean, obviously an informational approach is better. The problem is that you need very, 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 very large data sets, because you're not considering the data as a bunch of individual points. You're actually trying to populate distributions of individuals across the values. And that takes a lot of data. Fortunately now, there is a lot of data. So this is also a tradition of analysis whose time has come, because we can actually do it now. We can populate the distributions. So I want us to be that guy. Okay, here we go. The path of covariance. If you assume that measures of covariance are exhaustive measures of statistical association, you have actually assumed a whole bunch of other things too. Nobody tells you that. It's like the fine print. You have actually assumed that the distributional forms are Gaussian or normal or very near Gaussian. In fact, it's a subset of elliptical distributions that are the only distributions for which covariances are exhaustive measures of the structure of statistical association. A multivariate t-distribution, it's not even something very exotic. The covariance is not an exhaustive measure of the structure of statistical dependence of a multivariate t-distribution. There's other stuff going on. So you've either assumed that the joint distribution is Gaussian, or more typically, you are assuming that the conditional distribution of y on v is Gaussian, and you're hoping to God that the distribution of v is not too bad. Yeah. There's a lot of hoping, a lot of fingers crossed in conventional statistical treatment, and then concern after the fact with whether or not your presumptions were correct. But perhaps more importantly, when you've said covariance is the exhaustive measure of statistical association, you have fundamentally limited the kinds of theory and explanations that your statistical analysis can sustain. Because you have in effect assumed that basically a linear regression model, underneath that Gaussian form, there is a linear regression model for the partial distribution. So that for every single individual in the system, you're assuming this form. That may be appropriate, but you should be aware that you're making that choice. All statistical work, if you do that, boils down to regression analysis. All of the explanatory action is in the coefficients, B. And the very notion of what it means to explain y is cast as identifying how the expected individual value of y changes when the individual value of v changes. There's no interaction. There's no generative abstraction. It's just a statement of representation under which everybody is the same. And where to explain means to identify the parameters that regulate the relationships between the individual variables. It's all about you, and only you. It's your fault. That's the thrust. People see that? We can call this bivariate and individualist reductionism in statistical analysis. The better path takes a bit of math. I've been working on this for 10 years. I had a voice and hair when I started. But it's gotten somewhere and it's getting places. When we use informational measures, we make no distributional assumptions. We don't know what's going on out there. That means that we're not imposing distributional restrictions on theory. The array of possible theories that we can inform with informational inference is far richer, and it will include irreducibly social theorizations that make statements about the system and relationships among elements of systems, not characteristics of individuals. So we end up with a far richer understanding of what it means to explain, and we end up with a series of multivariate measures of association that are social, and what the paper develops can be associated with very clear generative content. That's arguably the main contribution of the paper. Okay, let me try this. So say we have two variables, y and x, or y and v. Say it's income and zip code, and we're interested in their association. What does the mutual information do? Well, the mutual information is a measure of association between those two that considers how likely it is that the distribution of income within each zip code is the same. It's a measure of association that's based on the differences in the distribution of income within each zip code. And technically here, in this definition, it's actually a measure of how unlikely it is that the distribution of income across the entire population is the generative form that gave us the distribution of income within each zip code. We know that the distribution of income within different zip codes are different. Yeah, for a variety of reasons, and actually quite complex, right? Not only because it costs a certain amount of money to be in a certain zip code, but if you are in a certain zip code, there's certain opportunities for you or not. Very complex, unknown set of, but it all resolves itself into different income distributions in each zip code. People with me? The mutual information measures that in a particular way. So it makes a statement of association that is not based on the individual values per se. It's based on the distribution of people across the individual values. It's a fundamentally different measure of association. It's based on statements about the system, about the distribution. Another way of looking at it for the physicists out there is that the mutual information is a measure of phase space reduction. As individuals interact, and their interactions affect their outcomes in all sorts of ways we don't know. The more significant the interactions are, the smaller the full realm of possibilities for the outcome of the interactions is. The more that I do something to you that affects both of us, the smaller the space for the total outcome for both of us is. That's what physicists call a reduction in phase space. The phase space is a measure of the space of all possible configurations that you can have in the system. Interactions reduce that in a way that we can measure, and that's how you can measure it. I can explain if people want. Again, a systematic understanding of association. Okay, now, good. I need like 2 or 3 more. Once you generalize the mutual information, do a bit of math. You get a number of identities for any joint distribution of Y and V. There are a series of statements that we can make that are always true. It's not a model. It's not a supposition. These are identities that are true properties of these distributions. Okay? The first one looks a lot like the linear regression model. Why? Because I have something to do with the variable Y being related to a bunch of bivariate measures of association. Notice it's not a model because I don't have Y of individual I equals ba ba ba. I'm making a statement about how much heterogeneity there is across the system in the values of Y. And I'm relating it to these measures of association between Y and V1, Y and V2 given V1, and so on. Okay? Now, the really interesting thing is that if, in fact, the distribution of forms are Gaussian, this becomes equivalent to linear regression. So linear regression is true as a special case of this deeper truth. But this is a deeper truth not about individual relationships, but about the distributions as a whole. People with me? So people tell me I need to give examples. I don't like examples. But the kind of social analysis that you can do with this is fundamentally different. The kinds of discourse that you support are going to be fundamentally different. Explanations are not going to be, I'm going to explain your Y based on your V. No. Explanations are going to be, I learn across the social group as a whole about the totality of the Ys when I learn about the totalities of the V1s. How significant is your gender? How significant is gender to a particular outcome? We can do that without having to assume a model of the relationships involved. That's pretty exciting. Okay, now, some of you have noticed, of course, that this is not just one identity because I can change the order of the V's. In fact, each one of these is actually k factorial. Can be understood as a structure of attribution of the association, right? So with the first term, I'm attributing a big chunk of the association, but I can do the permutations. Now, if I get up and say, okay, I don't know what the correct structure of attribution is because I'm modest, I can throw a non-informative prior over the possible structures of attribution. You do that and you do the math and you get something pretty exciting. This here, which for those of you who are familiar, it's actually a generalization of the Shapley decomposition. Information theory gives us that willy-nilly, just like that, which is pretty exciting. Now, in all of these explanations, these are non-parametric statements. They are robust for any distribution of form. Linearity is not a hypothesis. This is not a model. This is an identity. I'm making no assumptions about homogeneous processes holding for all individuals. Yeah. And to explain is cast as having to account for the total heterogeneity in the system, in the outcome. It's a very different understanding of what explanation is. And I will stop by leaving you just as a teaser with the thing I'm really excited about, which I'm not going to have time to explain, of course, but the other thing that falls out is a different way to decompose the entropy of Y that involves a series of multivariate measures of intersection that may actually be, from a mathematical standpoint, the more natural way to seek explanations. See, the human brain is funny. It's powerful. But we have habits, we have vices, and we like bivariate explanations. X, Y, X, Z. Well, nature doesn't give a shit. And this particular decomposition doesn't start from the bivariate bias. It just starts from what's the best unique decomposition that I can give you. Boom. Now we have to sweat the intuition, and it changes how we go about explaining on the basis of inference. But it's potentially quite powerful, and I think this is gonna go places. So I'm gonna stop there, and I want to thank you for your patience. Not least for the voice, but also for the slightly abstract and kind of scattered nature of the presentation. Thank you.
Thank you, Paulo. Ellis. I use this guy?
Full screen. Okay. Thank you, Bruno, and thank you, Paulo. You saved me some time on beginning to level a methodological attack against conventional econometrics. But thank you for everyone attending here and coming to see a discussion about, I think, one of the few on economic methodology and where that lands with heterodox economics. And I have a few points I want to make and a couple concepts I wanted to introduce. They're maybe seem abstract, technical, difficult concepts, but hopefully I'll show that they're quite intuitive. But I'd start by saying there's an unhealthy reliance of heterodox economics on orthodox statistics. And we need to acknowledge that. I'm going to talk about that a little bit, but introduce three figures here that are, I think we should see as intimately connected in pushing the boundaries of what we can do in political economy these days. We have the oldest, Reverend Thomas Bayes. We've got Karl Marx, which everyone is familiar with, and on the left there we have Edwin James, a great physicist who unified information theory and statistical physics. And it's one of the reasons that Bayesian statistics emerge today as one of the most important ways we can think about doing rational inference and statistical analysis, but one who is not read widely enough by economists. So I hope that if I can convince you anything out of this is there's not really much to read from Bayes. Laplace really is the one to read from him. We've all read Marx, but to pick up probability theory, the logic of science. Now, we know that in economic systems and capitalist economies that we see strong, robust regularities. Okay? Right? Market-based systems characterized by complex, self-organizing division of labor, and essentially around the process of commodity production and exchange, right? Specialized producers. And out of this arises, in classical political economy, things like the theory of value. And classical political economy, one of the most fundamental methodological precepts is that capitalist systems any social systems tend to produce laws and tendencies. Right? We talk about laws and tendencies. They organize the system. The system is not random. The system is not all over the place. In fact, there are very, very strong institutional constraints in capitalism, namely competition and wage labor, that tend to organize the system. And it has, actually, these are very strong organizing principles and institutions. It's a central method for classical political economists. And we want to talk about laws in a way. Now, these aren't laws in the same sense as physical laws. But the hope of classical political economy, of course, was that the laws of social reproduction, right, that we can study these laws for the betterment of human life and to actually understand capitalism. Now, the point is that these observed patterns that are quite robust are at the macroscopic scale. And these persist over long periods despite, when we interrogate the system, finding a significant amount of disorder at the microscopic scale. So, for example, the spontaneous formation of statistical moments in observable real social phenomena includes such things as average prices and incomes, and this is served largely as the basis for a lot of economic theory development. However, the reduction of statistical distributions of prices, and we know, of course, if you walk around and you pick out some prices of a particular commodity, you're not going to see a single price. If you look at firm balance sheets, you're not going to see a single rate of profit. We see statistical distributions. Now, if we reduce these statistical distributions to their mean values, this is certainly going to simplify economic theory. But this perforce neglects the existence of disequilibrium states and the determination of higher order moments that leaves many of the fundamental questions about the determination of equilibrium unresolved. Now, rather than to strive to develop a coherent statistical methodology that's hopefully capable of explaining a broad set of statistical features observable in real complex systems like capitalist economies, the core of economic theory and the highly sophisticated econometric techniques instead tend to reinforce a deterministic view of economic processes and equilibrium, leading to quite a poor articulation of theory and measurement. So we need to rethink methodology in a pretty fundamental way, I think. So now, when we think the organization of actual phenomenal observations in economic theory is going to inherently deal with problems of inductive inference. And this is due to the fact that the data we have, as Paulo expressed, is non-experimental and it's incomplete. Right? It's sparse, it's subject to measurement error. It's just very bad data that we have. So economics, though, is in a position where we do have increasing access to detailed data, but the explanation and the interpretation of this data requires a theoretical prior. And probability, particularly epistemic probability, and entropy are going to be the main tools for reasoning when faced with incomplete information. And if we want to express the conceptual foundations of economics in these terms, and I highly recommend that we think about how we can do that, most certainly enhance the articulation of theory and measurement, and also cast a new light on the problems of political economy. Now, there are a few things I want to talk about in terms of the methodological approaches to dealing with these problems, these fundamental problems of aggregation, right? The fundamental problems that when you start to think about an economic system, you're immediately confronted with its complexity, the fact that everything depends on everything else, and that if you take a detailed look at the system, it looks somewhat chaotic. But somehow, the system self-organizes and produces strong regularities and tendencies. Now, orthodox economic theory, which is born out of the marginalist doctrines of Walras and Marshall, they, of course, we know, tend to abstract away from statistical thinking altogether and emphasize the determination of stable fixed-point equilibria properties of what we'd call an abstract, completely specified economic system. In fact, there's no little doubt that Walras conceptualized economic equilibrium really as force balance in mechanics, in terms of the gradients of utilities. Now, the mathematical advances in general equilibrium theory, of course, aim to establish the logical consistency of the laissez-faire approach rather than to refine theoretical predictions for empirical research. And what this led to is the fact that general equilibrium theory is compatible with virtually any observation via some underlying preferences in technology. And it's not very clear exactly how to interpret the core structures of general equilibrium theory in terms of empirical observation. Not surprisingly, we see a turn away from general equilibrium and the turn towards economics becoming another applied social science, because it has the failures of general equilibrium theory to help to actually explain and predict real observable phenomena has been significant. Now, in the neo-Ricardian and the Marxian political economy, though, has also tended to reason in terms of abstract notions of uniform equilibrium, particularly in terms of prices and incomes, like the profit rate. And this is in some way a consequence of adopting long-period thinking. Now, in contrast to orthodox theory, though, don't get me wrong, I mean, Smith and Ricardo and Marx, they emphasized actually both the stabilizing and the destabilizing dynamics that are endogenous in economic systems. And they used this idea of this essentially statistical vision of an economic system of capitalism for conceptualizing what they eventually called gravitational equilibrium, we generally refer to this phenomena that we have long period states of equilibrium that are abstract centers of gravity, but we recognize that in the short term, capitalist systems produce endogenous fluctuations. And that endogeneity is very important because it's also can be descriptive of the type of processes that we want to understand and explain. And it will help to fix the problems of articulation and measurement in economics. So Smith, we know, was the first to articulate a dynamic theory to account for the tendential equalization of prices and incomes, and most classical political economists adopt some notion of gravitational equilibrium. And important to this is that gravitational equilibrium is, of course, determined by strong stabilizing feedbacks arising from competition. The main classical methodological innovation is that capitalism produces strong stabilizing forces, and that any conclusions that we draw about capitalism need to be drawn and rely on robust, pervasive, self-reinforcing tendencies. Now, the classical vision, though, appears to align most closely with a coherent statistical methodology. It's hard to avoid that conclusion when you read Smith and Marx. And although it does this, the analytical approaches that dominated 20th century political economy remained fragmented, neglecting Smith and Marx's essentially statistical vision of an economy. It wasn't. Now, Robert Langston in 1984 introduces a critique to neo-Ricardian thinking. He says, by considering critically neoclassical and Scharfenaker positions, I'm led to the concept of price, which reflects the volatile, chaotic, and ever-changing nature of observed market prices. In doing so, I attempt to show that the ceaseless movement of real market prices, while irreducible to a single deterministic matrix of ideal prices, is limited within certain determinate bounds. And following Langston's work, Farjan and Markover published The Laws of Chaos in 1987, but the idea that probabilistic methods can and should be applied to economics and that verifiable economic laws can be derived from means of statistical considerations is far from new. On the conceptual level, it can be traced back to Adam Smith and more particularly to Karl Marx, who stressed the essentially statistical nature of economic laws. Of course, Kurz and Salvadori recognize that a proper answer to this, to modeling gravitational equilibrium, would seem to contain of necessity an answer to many economic questions which are as yet unresolved. And as Farjan and Markover, is what began as a critique of the deterministic thinking in the neo-Ricardian tradition, discovers, they say, what began for us as a preoccupation with a purely internal problem with Marxian economics was enlarged to a general conception that bears on the foundations of the whole science. And this is a problem that's not unique to political economy or to neoclassical economics. This is a problem which is foundational to how we reason in economic systems. And if we want to better understand capitalist systems, such a methodology can be incredibly enlightening. So statistical equilibrium, I want to move to the concept of what statistical equilibrium is. There's two concepts I wanted to talk about. Entropic inference, the principle of maximum entropy, and the idea of statistical equilibrium. It's a very different way of thinking about equilibrium. Right? We think about equilibrium typically in terms of counting equations and unknowns, and when we solve for these, we end up with a fixed point, right? Some determinate answer, which is not what we see in economic data. Statistical equilibrium, this is a very intuitive concept I want to convince you. It identifies the stable configuration of observable frequency distributions as revealing important information about the relevant institutional, environment, and behavioral constraints that produce this, both the system's central tendencies, the sort of modalities for which we typically think of as the basis for theory formation, but they also identify the general, the fluctuations around these tendencies, these generative dynamics that shape these higher moments of the distributions. And we tend to observe those in economic data quite regularly. Now, the formal and rigorous development of these methods, so it's closely associated with the formulation of thermodynamics and of statistical mechanics in the 19th century. And statistical equilibrium provides, I'll argue, an alternative framework for conceptualizing equilibrium, which is actually quite consistent, I think, with the notions of equilibrium as inherently statistical in political economy. However, when we talk about a probabilistic approach to political economy, when we start to arguing for rethinking the concept of equilibrium in terms of observable frequency distributions that can be derived from theoretical considerations, is that we have to have a coherent theory of probability. If we're going to reason probabilistically, we have to know what probability means. And I'd say that in economics, we teach the wrong, incorrect theory of probability. First of all, we teach that probability exists as a thing. We like to make sure that we understand that probabilities do not exist. These are degrees of belief about systems for which we have incomplete information. Now, the model of statistical mechanics, in order to illustrate the ideas, basic ideas of statistical equilibrium, is an ideal or perfect gas. And when we think about the perfect gas, there's several possible derivations of the statistical mechanical analysis of this gas. And we see some of these pop up in economics. One of these is that physicists find plausible is an ergodic hypothesis, that the dynamics of the system are sufficiently chaotic and mixing, that over time the system traverses all possible states. But unfortunately, it's very difficult to see how to generalize this idea in other systems, in particular social and economic systems for which the ergodic hypothesis is highly implausible. Now, physicists often approximate a system's dynamics using drift diffusion equations as well to describe the evolution of the macro state probability distribution. Now, in bounded state spaces, drift diffusion processes, they do yield equilibrium distributions with ergodic properties, but many social and economic systems also do not fit this framework very comfortably, making it hard to interpret the drift and the diffusion parameters meaningfully. This is where Edwin Jaynes comes in, and he demonstrated in two classical papers in the 1950s that it's possible to derive statistical mechanic results with the framework of information theory. Now, Jaynes's derivation is to maximize the informational entropy of the distribution describing the macro state of the system, subject to relevant constraints on the variables. Now, in physics, in the sort of ideal gas example, this would be the number of particles, the volume of the cylinder, and say the energy of the gas. Now, these properties, these macroscopic properties, then the idea is to say, well, one way we can try to figure out what the most likely configuration of the system is, given these fixed macroscopic quantities, is to then think of an ensemble of systems that share these same properties and figure out what's the most probable configuration given these constraints. Now, this particular derivation has remarkable implications for the relationship of information theory to physical systems, and has even greater interest, though, as a method of computing statistical equilibria for any complex system, which can be easily adaptable to social and economic systems as well, if we can formulate the relevant behavior of the system in terms of constraints. Now, statistical equilibrium as rational inference requires that we maximize the unexplained fluctuations, the entropy of complex social systems subject to the constraints imposed by economic and social institutions and purpose of human behavior. If this asks, what type of information do we have about economic systems? Well, for Smith and Marx, they had very strong abstract notions that, that the information we had that was enough to derive a theory of value was based on the notion of competition, right, to begin with. The idea that the theory of competition, the central abstraction of classical political economy, right, what are going to be the outcomes from a theory of competition where capital and labor are free to move between different lines of production. Now, the ideas in the residual indeterminacy after we maximize our uncertainty subject to the information that we have about the system derived from theory is going to be the entropy maximizing distribution that satisfies those constraints. So entropy maximizing models predict central tendencies, again, as well as the fluctuations around these tendencies. And the relevance of a maximum entropy distribution and maximum entropy inference is, of course, conditional on the ability of the model to produce observable regularities in the system under analysis, which is what we'd like. If we'd like to be able to hold our theories up to the actual evidence, it's going to be very difficult to say that we have a uniform rate of profit and to look at profit rate distributions, which certainly do not look uniform. In fact, here's a picture of empirical rates of return. Farjan and Mach, over in the laws of chaos, they conjectured that those distributions of profit rates should probably follow a gamma distribution. Now the idea here is when we look at a frequency distribution like this, and this is a gamma distribution fit to this. This is tens of thousands of observations of firm profit rates. And I'd say that it's a pretty good fit. It's not a degenerate distribution. If, of course, there was no uncertainty, that distribution would be a degenerate distribution. And there would be zero entropy, because I hope to understand that entropy is a measure of our uncertainty of the system. Now, what's fascinating about this is when we look at actual observable data like profit rates, we can then ask, well, what is a statistical model? Right? How can we think about deriving a model which predicts not just the average rate of profit, but also why does this distribution follow a particular shape, in which case it clearly has fatter tails, and it's skewed in this case. And if we look at more detail, we can see that this is histograms where we take the midpoints here and fit the distribution. And you can see that those distributions remain remarkably stable. This is back to 1951. So, Stephen, here's evidence that monopoly has not fundamentally changed competition. Competition is one of the most fundamental organizing principles in capitalism. And if we look at actual profit rate distributions, we can see that it does so at a pretty regular frequency. Right? These distributions here are organized every year on the exact, these are here are scaled and shifted to show, or standardized to show exactly that the same signature arises, the same distributional signature arises from competition. Now this also happens, this happens to be a scale-free phenomenon. Now if we look at the distribution of profit rates across the size distribution of firms, those distribution of firms in the smallest 5% by firm size or assets, up to the top 95%, all follow the exact same organizing principle. They all follow the same distribution. Competition is a remarkably strong organizing institution in capitalism, and we should expect to see this type of evidence in profit rates just because of how important of an institution that is. Now the other, of course, is wage labor. I want to look at ways in which wage labor organizes just the everyday behavior of individuals. There are strong organizing principles. People get up, they go to work. They're fairly predictable, and these predictable constraints tend to lead to observable regularities in the system that we can relate to classical political economy as well as hold up to the evidence to see, to help us to explain the evolution of these distributions in terms of economic theory. Now I'm going to skip, there's the idea of how to model statistical equilibrium. Now, Paulo talked about this a little bit, so we want to model equilibrium frequency distributions, we want to account for the observed regularities, and we want them to be theoretically interpretable. Gaussian distributions don't do us very well in economics. They can be rationalized through the central limit theorem, but this requires mean independence, right? It basically purges, much like general equilibrium theory does, social interactions from theory And the central limit theorem is one way in which social interactions are approached from the statistical perspective of how we might rationalize those distributions. It breaks down, that is, the central limit theorem breaks down with cumulative causation, with feedbacks, interdependencies, and network externalities, and strong strategic complementarities. This is one reason why modern causal econometrics has such limited domain, because it assumes away from the very beginning general equilibrium effects. So I'm going to skip this because I wanted to get to the point here. So yeah, let's go to general method of inference. So entropy maximization is a way of solving for an equilibrium in the system. Now, equilibrium is not, again, a degenerate distribution. We're talking about equilibrium as a frequency distribution. Right? And this turns out to be critical for a general method of inference, because in economics, we tend to possess two types of information. One is theory. One is information in the form of moments, such as the general rate of profit. The other is data. Now, data directly enters our inferential process of the likelihood. Right? We're all taught how to maximize the likelihood, but if we deny our priors, then we deny an rich set of information that we have in order to shape our inferences. In general, framework for inference has to be able to incorporate both types of information, theory and data. And it's only with Bayes' theorem that we can do that. Data enters the likelihood, modifies the posterior through consistent updating, and theoretical information modifies posterior probabilities by constraining prior probabilities to be consistent with the information. It's the only general logical method of inference that consistently does this. And it leads to statistical equilibrium theory considerations. So I didn't show you here. One way in which we can derive that probability distribution is through Marx's insight that social surplus at a point in time is conserved. And conservation, this theoretical principle of conservation of surplus leads to moment constraints. Now, those moment constraints, of course, give rise to a predictive distribution, an equilibrium distribution. We solve not by counting equations and unknowns, but we solve by maximizing our uncertainty subject to the information that we have. And the result is an equilibrium frequency distribution, but we don't necessarily know the parameters that govern that distribution, which is why it requires additional uncertainty over those parameters. The first part of logical inference is to include the information we have in constructing our priors. This gives us the functional form of our models. Now, when it comes to estimation, then we have profit rate observations. So we put our profit rate observations through the likelihood, and now we've been capable of incorporating both types of information into the process of inference. Okay, last thing I'll say is on the poverty of econometrics. The predictive and the explanatory success of econometrics right now has often been only in substantiating our primitive intuitions about reality. Right, as heterodox economists, we teach students about capitalism. We want to know about totalizing theories. Right? What is capitalism? How can we understand its internal logic, its laws, and its tendencies? Right? The fact that capitalism develops in particular ways, but we deny students a empirical strategy for doing so, because you're never going to learn anything about capitalism with a difference in difference equation. They simply can't handle that. And first, the first thing that econometrics does, as Paulo pointed out, is to abstract away from complexity, is to purge the basis from social interaction. And if we want to rebuild in social interaction, build in an imagination that can incorporate classical political economy notions of what capitalism is, we need an empirical strategy to do it. And this is one way for doing that. So I also recommend reading Aubrey Clayton's work. If you want an introduction to Bayesian thinking and the logical fallacy on which modern econometrics is based, I think that's a good place to start. And the other is a book that is just completed with Duncan Foley and myself on the use of Bayesian statistics and information theory called Making Statistics Work. So that'll be out later this year with Columbia.
Thank you so much, Ellis. Now, Doguhan.
Hello. Thanks for being here and thanks for inviting us. Jisoo, Bruno, Clara, Scott. Very inspiring event. I picked this title, but I will try to start with maybe a familiar story to quite a few of us here. I tried to get the exact story from Duncan Foley's Understanding Capital. So late parts of the book, there's this part that goes long run tendencies of capital accumulation. So let's say I'm a firm. I'm competing with other firms. One way of doing that is finding a new technique that would produce the same good for cheaper, right? So if I'm able to produce for cheaper, I can either sell for a lower price and get rid of you as my competition, or I sell for the same price and make more profits, right? That's competition to you. One vision says that process is biased, right? So a way of doing that is coming up with a machine that would replace workers, right? You fire workers, pick a machine that does the same job for cheaper, and you create what we call reserve army of labor, or enhanced, right? So you have more workers unemployed now. While this is happening, if you're the winner of the competition, you have profits that you can use for reinvestment, you grow. Also, the losers of the competition, maybe you acquire them, right? You capture them at the same time. So these two we call concentration and centralization. I avoid the word monopoly for a reason now. It's going to make sense in a second. But if you're a worker that still keep their job, the picture for you is also a bit interesting because first, maybe a couple of years ago you were making the shoe from scratch, right? You had the skills, you had the bargaining power over your boss. And now your job is integrated with machinery and you have to just pull down the lever, which, no offense, anyone can do. And the bosses know that, right? That's why they brought up the machinery. So you are de-skilled as the worker. And even if your real wage is increasing, chances are you created more profits for the company than your real wage increase. So that's what we say, impoverishment of workers. So the result, I guess quite a few of us are familiar with the story, is emergence of institutions to organize production on a centralized basis. This is to say, now you know how to feed, clothe, and house people as the workers. Every time you come into the factory, you know how this is done. It's just there are bosses that control that process. And second, we have a massive number of people either lost their small businesses and they're unemployed or workers now. They're conscious of what happened, right? So machinery came in and I'm unemployed now. Possibly they're also politically active, right? So this is what Marx calls an era of social revolution, right? So the material formation or change leads to a change in the social structure, hopefully. I will make the bold argument that I believe a good chunk of 20th century debates are focusing on this last stage, right? So do we have a massive number of working class or do we have new petty bourgeoisie? Or do we have mass number of workers, but what about their consciousness? Like they're workers, but they're also white, they're men. There are other factors that determine their consciousness. Or let's say we are good on both fronts, but the political formation, right? Like how are they supposed to organize to, I don't know, change the world or something? I will argue the problem actually is in the first stage, the biased technical change argument. It's not a problem, but let's say, again, quoting Marx, no capitalist ever voluntarily introduces a new method of production so long as it reduces the rate of profit. If you really think about it, why would you create your own grave diggers, right? If you were able to avoid that, if you were able to create this process, or if you were able to avoid the process that generates large number of unemployed, mad people, you know, they rely on you, they don't want you as their bosses, or they don't want you to control the world. Maybe there was a better deal you can come up with where a good number of the working people are happy, although they are not the bosses, and just keep making your modest profits. And there's another reason that this is a problem. When you introduce a new method of production, and state, I think, comes in here in terms of their intellectual property rights, regulating competition, other forms of intervention. If you're able to come up with a new technique that anyone can copy, then we will all have lower costs, we will all have to reduce our prices, and what we have, lower profits for everyone. Right? That's our common demise as the businesses. So there are many reasons for capitalists to avoid competition. And in a sense, and you get this in Duncan's book, but also I think John Elster's study also makes the same point, capitalists find themselves in a situation that we call prisoner's dilemma. They can coordinate each other's actions, right? They can avoid competition if possible, in which case the whole story that you see in the first slide falls apart, right? If I find a way to avoid introducing more productive techniques, cost-cutting techniques, machinery, large-scale production, if I don't do that, you don't do that, we both make profits, and all the other steps don't take place. Well, of course, if you know from Prisoner's Dilemma and if you know from Marx, the argument actually is correct. The rational thing to do is to adapt the new technique. The correct, if you will, the profitable thing to do is to, whatever my competition is doing, I think I should find a way to produce this for cheaper and we'll see what happens. But then in experimental evidence and in real life, we know people still coordinate. They find a way to cooperate, if you will. And so do firms. And if they manage to do so, firms are going to be able to avoid competition, and they are going to collude, form cartels, merge, and form monopolies. Now I say monopolies, right? That's monopoly. Now you don't have competition in the sense that if I cut down the costs, there is no you. I bought your business as well, right? That, I think, is where uncertainty lies in. Because just by observing, let's say, the general profit rate, just by observing the concentration ratio, number of workers, firms, you don't get to know what the firms actually did. Did they all increase their size at the same time? Well, if that's the case, then concentration ratio is going to be the same. Just by observing those ratios, we are not able to tell if the firms took all those actions that is going to create their common demise. And that tells us we have to come up with theories that are able to explain empirical regularities, right? Whenever you look at reality, you're going to just observe chaos, pretty much. Although our theories are suggesting a common profit rate for the same sectors, doing the same activity, in reality, it's going to depend on firms' ability to avoid competition or not, and there simply is no law in constitution or something that tells them if the profit rate is 5%, you have to invest. No, it's a choice. So our theories should, I believe, do two things. First of all, they should be able to account for these empirical regularities. Second, it should really take into account choice, right? The firms do have the ability to avoid competition when they can, let's say. So, as everyone brought up, Fajon and McCover's work, refers back to laws of chaos. I think I quoted their New Left Review article here. The quotation goes. Right, so at any given moment in time, the individual observations cannot be inferred from the macro variables. Just by observing the general profit rates, you don't exactly know what the firms did, right? I think it's very intuitive in some way. By the way, I think the spirit of the conference, Fajon and McCover, both prominent members of Matzpen, an Israeli anti-Zionist organization, do read them. They have amazing work on apartheid. Following Majd and McCover's work, Anwar recently in a journal, Ellis was the editor of, guest editor of, makes the argument that, it's all good and great that we have some theories to explain these empirical regularities, but, there's got to be some explicit economic processes leading to this, right? Just because you observe these shapes doesn't really tell me what led to that. I agree with that to the extent that I don't think the mean reversion idea is also a law in the sense that, let's say, I have high profits, you want to enter to my sector, you bring some goods, and now my profit rates are down. Well, sure, but that's not a law. That's a choice you made, right? We could maybe do a handshake and avoid competition and find a way to be, profitable still. So choice, I think, comes into this question in Ellis and Duncan's work when we start looking at these observed distributions jointly with choice. Right? Entry and exits are decisions. You may choose not to enter a sector, in which case all the other part of the story, right, the skilling, whatsoever, may not follow. There are also some other reasons to focus on the subject, right? The negative feedback and satisficing behavior, I refer to Herbert Simon here, are not stuff that we get from the balance sheet information. So pretty much we need some methods that are informing us about these unobservables. To do that, we keep saying empirical regularities, so I'll bring three examples here. Germany, France, and Great Britain I pick sales data for these 3 countries from 1989 to 2023. And then you just pick a company's sales, divide it with the total sales, what that everyone else does, right? That's the market share technically. And then take the logarithm, don't worry about it. It just turns it into a bit more visually appealing and I think fits better into literature. And then you get these shapes. Darker the color gets, more observations you have, right? So you look at the early 1990s. First and foremost, I want to point out the scale is a bit smaller, right? The variation is smaller. So the largest market share business was not that far away from the lowest market share business. That changed from 2000 onwards in all 3 countries. This is the same in the United States, I'll come to that. And more importantly, I mean, you don't really see everything all over the place, right? There's some sort of order. If you're able to notice, the top and bottom are both very light colors. In the sense that we are talking about a hill. We are not talking about a bunch of hills. So there is, like vast majority of businesses are sharing the same market share. There are some businesses with extreme market shares, you know, they're very large, and some are very small. And that's been the case in 1989, 1990, 2023, never changed in all these developed capitalist economies. So I want to have a theory that would be able to account for these empirical regularities, but also informing us that, you know, what do firms do, right? Did they really compete to death or something else? One way of doing that is, again, using the model Ellis and Duncan developed. Let's say you want to have a market share that I denote with S, that is above an aspired level. So you want to be a firm that is selling more than 50% of the market demand. Then you would try to expand, right? Although, you know, if you want to be a small, modest, but sustainable business, you may want to shrink, in which case I have the mu minus S kind of situation. That's the payoff, you know, very straightforward, I think. And another constraint we will add is, you know, if I were to add one more person that is taller, the average height is going to go up. So when I try to expand my size, the average goes up. You know, that's pretty much it. You know, very modest assumptions about the system. And that gives us this 3 examples. So here I have, again, Germany, France, and Great Britain in order. And the bars are data, and the line is the model. Does a good job in fitting. I picked the years 2020 and 2021 for a reason, because if you're thinking, you know, you talk about regularities, what about COVID? What about pandemic? These big distortions didn't matter, right? The order of the capitalist markets are remarkably and shockingly strong. Right around pandemic and post-pandemic, these shapes remained pretty stable, just like they were in 1989. So, you know, model does a good job in at least accounting for that. And something more important, I'll try to be fast, I promised everyone. So one thing, the mu here, I think, can be interpreted as aspirations, right? I mean, as a business, you don't really know what your competitor's marginal cost is, their cost curves, their capacity, their CEO's name whatsoever, number of people in the board of directors, but you have some aspirations. You feel like, I want to be, you know, 5% market share this quarter or something. So that's mu. The aspirations are declining in Germany. You'll notice it's the same pretty much all big European economies. So 2000s onwards, that aspiration amount is pretty low. T is representing variation in behavior, right? I mean, just because you had, I don't know, big aspirations doesn't necessarily mean you're going to act on them. It appears overall in the system, this, you know, I'll take my chances behavior is increasing persistently, which leads us to the result of the probability of expansion is declining in Germany persistently. So you see the last figure here is the probability that a firm is going to say, you know what, I'm going to compete to death. They didn't, you know, they did the smart thing for themselves. They avoid de-skilling their workers. That means now they have rents they can share with their workers. That says a lot about the working class struggle in Europe. Because you see the same, somewhat same in France, but definitely the same in Great Britain. In Great Britain, in fact, the probability of expansion goes all the way down to 50% post-2007 crisis. One thing interesting, I think Great Britain is showing this, if you will, you know, mu getting better, right? So at some point they were happy with very small market shares. Recently, I think post-2000s, they're trying to expand their market shares as well. Last 2 points I'll make about the estimates. I don't think he's here. The president made a point about John Robinson's path dependency arguments. I think it's very important, what you expect versus what you get. Right, so let's say our mu's are what you were hoping for versus alpha is what actually happened, and the scale is persistently negative. That is, people desired less than what actually happened in European economies. I think that is consistent with the fact that they avoided expanding, right? So I wanted to be a modest business, and I am a modest business, right? So whoever is the biggest business out there, good for them is what the typical business's idea is, but that deal appears to be very fragile as well. So our friends in Europe, good news. If the firms start to realize, everyone's trying to get the same firm size, market share, then I will fight to death. That appears to be persistently present in all three countries. Okay, I'm wrapping up. All right, conclusions. I think the first two are a bit boring. I think uncertainty is inherent in competitive markets, and our methods should account for that. There really is no way of escaping this. Second, probabilistic reasoning, in my opinion at least, puts the emphasis on decision-making process, right? So when you're speaking of the gamma distribution or something else, it raises the question, okay, what type of processes lead to that regularity, right? That I think also tells us, you can't just assume what people are doing, right? I mean, based on the observations, you're able to infer what people may be doing. Versus, the traditional deterministic views are going to have some fixed causal mechanisms repeated again and again. But about the political part of the subject, we have to admit capitalist accumulation allows diverse outcomes, right? It's not necessarily the case that just because we have capitalism, firms are going to compete and they're going to compete to death. I think I try to convince you in continental Europe, well, no, is Great Britain included in continental Europe? Costas, okay, thank you. All right, so in continental Europe plus Great Britain, they are able to avoid competition. And that means they're colluding and they're able to alleviate conflicts. And that is all possible due to managerial discretion, right? If someone's making the decision to avoid competition, it's the board of directors, is the manager. I didn't cite anyone here, but when I say industrial society, I'm referring to Adorno's debates, managerialism, Gerard Duménil and Dominique Lévy's contributions, and neo-feudalism, both Varoufakis and Jody Dean is coming up with a book on this subject. I would say, I think we should definitely hesitate before calling out for qualitative changes. Same capitalism allows you to get into competition or avoid competition. That's the same capitalism. Just because you see decline in probability of expansion or competition doesn't necessarily mean competition is dead, monopoly capitalism whatsoever. That is still competition. Just to point out something similar to that, this is a published paper using a similar model for United States. For United States, the probability of expansion is going up. I don't think this is surprising. You know Amazon, you know Tesla, you know this, you know that. We are definitely facing giants that are, their business model is pretty much buying any small competitor in the market. That's still competition, right? You're still buying out your competitors. But this leads to a different outcome. This leads to de-skilling. This leads to unemployment. This leads to unhappy workers. When I live in Southern California, a good chunk of my friends are Amazon workers. They used to be college students working with Students for Justice in Palestine, and now they are trying to unionize in Southern California. I don't think none of these are by chance or hard to foresee. This accumulation process is leading to organization for working class, and I think probabilistic methods kind of helps us to think about these subjects. Thank you.
Thank you so much, Doguhan. Now I'm abusing a little bit of my power here, and I will present as well. Let me control the time here. All right. So, when we were thinking about this panel, we had Ellis and Paulo with more abstract ideas, which are not abstract, but they are more the foundational aspects of this entire endeavor that we call probabilistic political economy. And Doguhan and I, we are basically trying to show you some pictures and guide you through some of the applications that are that we are working with this methodology. So I'm presenting this paper, which is basically a work in progress, and I hope to get some feedback from you. So, because I was the last one to speak, I can skip some stuff. But I just want to emphasize one thing that was discussed here earlier, which is this capitalist reproduction process is a cyclical process. And because of the cyclicality, we have some stable patterns that arise over and over and over again. And we can use some probabilistic models in terms of central tendencies and fluctuations around those tendencies to explain this regularity. I'm applying this methodology and this probabilistic political economy into the understanding of the profit rates for the American economy, for the US economy. We know that there is this description of the process of what we call competition and/or profit rate equalization, in which capital is going to move from low to high profitability sectors, or what's important here is that this process is going to induce what we call a negative feedback effect. Basically, if you are in a sector and there's another sector with a higher profitability, you're going to move into that sector. Obviously, I'm ignoring all the assumptions for making capital to be mobile and so on and so forth. But if you can move into that sector will have more suppliers, meaning that the supply will increase, the prices will decrease. Because the prices will go down, the profits will reduce. So initial profits attract people. Because people enter in that market, there's this convergence to the profits going down. So this is going to create the cyclicality in the process. This, and I'm calling here is a hard word, misinterpretation. Classical theories assume, and this includes neo-Ricardian, Marxian, traditional views on this process, we use it to assume a uniform profit rate. But as was discussed here, when we take real data and see real data, we see profit differentials. We don't see the same number, basically. That's what I'm saying. What's the alternative? To embrace probabilism and to use probabilism to explain how the economic variables are inherently statistical, uncertain, and we are going to focus on how we describe the probability distribution for these variables. As I'm working with the profit rates, there are two competing models that we can apply to understand the distribution of the profit rates in the US. I will talk a little bit about the data that I'm using later, but this is just a general view about what we can use to describe how the profit rates are distributed across the US. We have these two models. The first one, which was already brought here, which is the Fajon-Machover's gamma distribution. So this is one way to work with the profit rates, which is the top picture here. We have different distributions, different forms of the same distribution. That's a gamma distribution. What is interesting here is you can see this distribution starts in zero. We don't have negative profit rates. The alternative that we have is the model that was developed by Doguhan and Ellis, called the quantum response statistical equilibrium, which I'm going to refer as QRSE from here now. Okay. What's the difference between the two? In the second one, we have a Laplace distribution that we can account for the negative values for the profit rates. What I'm doing in this paper is basically working with these two models to see which one is the best one to explain the US economy. The data that I have in this paper comes from Compostat, and this data is a balance sheet data that we have. In this case, I'm working with from 1951 to 2023. We have more than 20,000 companies, so it's thousands and thousands and thousands of lines in a spreadsheet. So you can imagine how big the data that we work this can be. I'm working with public companies, and how do we define the profit rate? Usual thing, flow of profits over stock of capital. In this case, I'm working with the return on assets, so I have in the numerator the sale minus the cost of values, the cost of goods sold, and I divide this by the total assets of that firm. That's it. But we also do something that's important here, which is accounting for the weighted capital. So we have this weight here, which is basically the relative size, and I'm calculating size as the total assets of the firm, so the relative size of that firm given the entire market. And let's go back to this thing here. Why we use weighted profit rate? That's a question, right? Because we can just work with profit rates or weighted profit rates. In this work, I work with weighted profit rates, and these 2 bullet points here, they explain the exact difference between these two. So the unweighted, ignoring the weights, is going to count the firms per rate interval. So we're going to have intervals where in these intervals we are going to have the profits. In terms of the weighted profit rate, we have the profit rate that reflects a firm's profitability relative to the total market invested capital. And this is a very long quotation from Marx explaining why this is important. So working with this data and calculating the weighted profit rate, we have this, I just got some different, here we have 4 decades, so we have the 60, so not the entire decade, that's the year, but representing the decade, so 1960, 80, 2000, 2020. What we see here is using the gamma model, which is ignoring the negative profit rates, we see there's a good fit. So what we have here is all those bars and those spikes with the dot over there. This is the data that we have. In red, we have the distribution that's trying to fit that data with this model. We can see that the gamma is a good model to fit this data. And what else you see here is that there's some sort of regularity. The shape is not changing that much over time. And I'm going to echo here what other people said about institutions of capitalism are persistent over time. When we have this entire, when we do this work, I'm avoiding to go back to physics and talk about thermodynamics and all those things, but what we're doing is basically, we're trying to assign probabilities to states. So we have data, and we are basically trying to understand how can we explain this in terms of a probability distribution. So following, as was presented here, James, who recognized the generality of Shannon's entropy maximization process, we can do that. That's a suitable way to do inference. And let me read this in red here, because I put in red because it's important, right? So maximizing Shannon entropy with economic and institutional constraints yields probability distributions describing economic variables, meaning that we are going to do a maximization problem. We are maximizing or optimizing this Shannon entropy, which is going to be a generic distribution, and we start to add some constraints that are going to carve this distribution until we see the shape of the distribution. That's basically what we do. Where those constraints are coming from? From our theories, right? So that's what we do in terms of testing those two models here. For the gamma, I am trying to avoid as much as possible the mathematics here. But this is what we call the gamma distribution, this ugly guy on the left. We have some key features. So you describe this distribution in terms of a shape and a scale parameter, which is basically how we can make this to spread and spike in this diagram that I was showing you. One important thing for this model is we are working with positive profit rates. And when we work with this model, we see, I already showed you the graphs, that we are in a certain way confirming. FM is for Jean Machover's conjecture, because in their book, they suggest that the profit rate follows a gamma distribution. How can we come up with a gamma distribution? We're going to need to add some constraints that are going to deliver the gamma distribution as the result of our optimization problem. What is exactly this constraint? That's what we have here in bold. The constraint that generates this distribution is the capitalists are going to have a strategy, and this strategy is basically to try to protect themselves, and they're hedging against investment uncertainty. And this is, we model this with some logarithms. Nevertheless, I mean, let's ignore the mathematics, and this is basically capturing the deviations that the capitalists can have from what we call a fully diversified portfolio. So they have different investment strategies, and they're trying to protect themselves to some uncertainty. When we run this model, we have those results here, which let me jump here and explain them in words. What we see from the distribution, and let me just tell you who these guys are. So we have here, top left, alpha, top right, beta. These are the parameters. They are explaining the shape and the position of this probability distribution. And here we have the standard deviation, and here we have the mean and the mode of the distribution. What these four pictures tell us is this thing over here. The gamma distribution shows some statistical equilibrium in the data that I work from 51 to 2023, but I'm working with a more broad measure. It's just the return on assets. If you want to approximate the surplus value to have a better profit rate, we can use a narrow measure. So, for example, we can subtract the selling and administrative expenses. But in this paper here, I'm working with this more broad measure. Given those graphs, we see that we have basically over time the shape is very similar, but it's moving a little bit, and we have a higher peak at smaller values. So the distribution is shifting to the left, and it's getting taller. The mean and the mode, they decline over time, and this is an interesting result because this is, in a certain way, is challenging some of the claims that the neoliberal years were years for the recovery of the profit rates. And finally, remember, this is a work in progress, so this is speculation that I have. This profit rate volatility, I think it's part of the explanation of the results we have in terms of explaining that financialization shifts the investment from production to finance. Okay, we have a good model that fits the data, is motivated by a meaningful hedge strategy, but we are ignoring negative profit rates, right? Which is a problem. They exist. Firms can make losses. We have another model that's going to be the control response model that can incorporate that. But to explain this model here and to motivate this model, let's think about the following. We have two types of elements in this process. We have observed and unobserved elements. What are the observed? What are the numbers that we have? The profit rates. This is the data that we can use. What is not observed? The action the capitalist is taking. Because I was explaining to you that higher profit rates are going to induce the migration from one sector to another, or low profit rates will make them to leave that market. We cannot see them doing that. We don't have data. I'm leaving, I'm entering. We don't have this data. So we come up with this, actually, Ellis and Duncan, they came up with this model, the quantum response model, and we can express, given the data that we have, all this narrative or all this theory about how we have this cyclical movement in terms of conditional probabilities. And we can think about these two guys over here. So we can have the frequency of the action. What are the two possible actions? Enter or exit a market, given the level of the profit rate they find. So I'm a capitalist. I need to decide what I'm going to do, given what I see. This is one part that we can model. The other part we model is what is the other effect? What is the effect that we see in the profit rate given the action the capitalist takes? And working with the model with these features, and we can show another ugly equation here. That's going to be the quantum response statistical equilibrium distribution. What we're doing in this model is basically trying to come up with what's called in the statistics a joint distribution. So we are basically trying to explain a result that at the same time shows the distribution of the actions and the profit rates, given all these features that I showed you. And you see that we have a bunch of Greek letters here and different letters. Who are these guys? In the gamma distribution, we had the shape and the location, and here we have mu, t, alpha, and s. Why these guys are important? Because mu is going to be the tipping point profit rate, which is in that tipping point, you have 50% chance of entry and exit. So that's an important variable that the capitalist is considering. We have the addition of something important, this literature called the behavioral temperature. That's basically in the way we set up the problem. It's going to account for the sensitivity the capitalist has in terms of experiencing different profits. We have the establishment of this, what we call here a social determination, which is basically the given profit rate on average. And we have this equalization scale, which is the inverse of the Lagrange multiplier, blah, 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 right? Just an important feature here. But how can we generate this distribution? We need to add some constraints to the maximization problem. Which constraints? This in bold here. So we have the expected profit rates conditional on entry and exit difference. So we need to account for how this is affecting the distribution. We put the alpha, which is this central tendency, so the mean or the mode of the distribution. We play with these guys, and we can show the parameters for this distribution. Again, these are just ups and downs here, so let's interpret these guys. What can we see when we use a model that accounts for the negative profit rates, which are a feature from reality? We see these things here. First, the tipping point profit rate. Remember that 50% chance of entry and exit. This has declined over time, reaching a low equilibrium since the 80s. We can see that over here. There's a declining mu. After the 80s, this is quite stable. In terms of the translation of this mu behavior, you have the firms are now entering and exiting the markets at lower profitability levels. In a certain way, we are shifting the decisions to the left in the x-axis. We have the behavioral temperature that accounts for that sensitivity of profit rate differentials, and we know that when this number is high, there's going to be smoother transitions or entry and exit responses. When we have a low number for T, they are the decisions they usually cluster around this mu that we have. In terms of the data that we see here, this sensitivity, this increased from the 70s, this peaks in the 80s and follows a pro-cyclical pattern. In terms of the other parameters that we have for this distribution, the central tendency basically declines during recessions, and that scale that I told you, this is technical Lagrange multiplier guy, it's a contracyclical guy. What is the, if you wanna just remember something here, since the 80s, more firms are surviving despite the negative profits. And this has generated this idea of the zombie firms and all this literature on that. But basically, firms, in a certain way, adapted to this new reality. Here I show you the two models that I'm talking about. We have different years. You can see the data and the fit with these two models. And what we see here is, let me see, the red one is the quantum response and the blue one is the gamma. You see that both of them explain this data really well. It looks like the quantum response is a little better because we are accounting for something that the gamma is ignoring. So how can we decide which ones is the model we should work with? There's something we can calculate called the Kublik-Lieber or KL divergence, which is basically how different is this distribution from this other distribution. What is this distribution? Reality. What is the other distribution? The model. So we basically try to see which one is closer to reality. What we are looking for here is the low value will be closer to this distribution, right? So what we have, I tried to fit this data with a log normal, which is a third alternative here. And what we see is that the green is usually below the other two colors. How can we summarize this entire thing? The quantum response has a better fit. And as expected, this has a better fit because we are incorporating the negative profitability, which exists in reality, right? Also, I did not explain to you exactly what is alpha and beta from the gamma, because it's hard to interpret these guys in terms of what they exactly represent. We can do that, it's not that hard, but the quantum response is much easier. I told you, this guy is the 50%, this guy is the mode, so it's much better to interpret, and this is more consistent because we are using this negative data as well. This is, for all the years in my data, how these two distributions are changing over time. What we see in both of them, there's this movement from basically the blue to the red. So the distributions are shifting to the left and getting taller, right? So we are concentrating on lower profits, and we have this movement over here. Going to the conclusions here, what all this statistical discussion explain, or what's the take from here? First of all, there is a fundamental stability in more than 70 years, actually 72 years in the data. There's some recurrent pattern occurring in competition in capitalism, period. We see that the firms can sustain some negative profits since the 80s, so that's an important feature, and this was discussed in the literature, but this also appears here. And this is the one thing I want to emphasize that I'm saying here, the persistent despite surface level change in capitalism. Even though some stuff have occurred from 51 to 2023, there's some stability on how this variable is distributed over time. So there are some institutional, there are some institutions in capitalism, one of them is competition, that even though things are changing, this institution persists over time. And this goes against the claim that we have perfect or imperfect competition, and this change from more perfect competition to more monopoly-led economy. And at the end of the day, when you go back to Marx, what is competition? Competition is not a matter of a spectrum. It's not more competition or less competition. Competition is the inner nature of capital. It's basically the interaction of multiple capitals trying to get more profits or more surplus value through exploitation of unpaid labor time, right? Capital competition is a process as a whole. We learned this from Rosdolsky. So competition is not perfect competition, imperfect competition, monopoly. No, competition is just competition. That's it. It's stable over time. I'm going to skip this guy here. This is basically how we see the quantiles, and let me go to the key findings to wrap up here. So we have this stability for more than 70 years in both distributions. However, the quantum response is a little better in terms of we use negative profit rates, so we are not ignoring a feature of reality. Second, it's easier to interpret. Competition is a process that it's not a matter of a spectrum, so we are not talking here about more or less competition. Competition is competition, period. And the thing that I was skipping here is we have some dispersion after the 80s, and there's some stability on the 90th percentile divided by the mean, by the 50th percentile ratio. This is stable. This goes against some of the literature that we have, but that's all for today. Thank you so much. Okay, now let's open for questions. I will take the mic to you, so just raise your hands if you have any questions, please.
Hi, everyone. I'm Deborah Nunes, assistant professor at Monmouth University. Thank you all for this awesome panel. It was really thought-provoking. I have a couple of questions, and it's for all of y'all, so whoever feels like answering, I would love to hear your perspectives. The first is, given how the mainstream field organizes within our discipline, they tend to be more welcoming to more applied perspectives when you try to challenge them, mainstream perspectives through those methods. So I'm curious to hear y'all's experiences at trying to approach more Bayesian techniques and in terms of publications or invitations to more mainstream spaces, and how, if they're closing the doors like they always do, or if you think that's a venue that maybe we can try to punch those walls or do some fractures in the mainstream economics. And then the second one is that you know, when we do more applied work, which was the case of the 2 later papers, which I really appreciate, we tend to do more applied work to developed economies because that's where the data is, and we can have longer terms, which is inherently what you need for this type of historical analysis of profits. And so I was wondering if you have any projects or any initiatives to try to see how those movements are happening in countries from the global south, or if you have any line of work or preliminary data to share with us, if you can see the same types of trends. Thank you.
It's hard to take notes and anyone else?
Okay, hi, thank you. Thank you so much for the amazing panelists. I have a couple of questions or comments. Yes, I am Andres Lazzarini. Hello. So first, I would like to know, why is it that, you know, if you take the earlier neoclassical economists like Marshall or Wicksell, Walras, etc., what would be actually the very silent difference between them, not Arrow Debré, but them and the classical political economists in the view of how the equilibrium process works out? I think that they tend to be the same in terms of basically the competition is competition and the condition is free entry. Independent, I mean, the condition will be the size will be changing because of technical change and so on, but as long as you have free entry, you know, you have competition, and I agree with that. So what would be the difference? And the second question regards, you know, equilibrium determination in theory is like you are not going to reach a value or an interval of value. You are sort of reaching something which you will never reach. Actually, it's like a lake which is sort of fluctuating, and you are trying to describe the processes or the wave of that lake, basically. In that regard, the equilibrium adjustment can be considered more or less consistently if you make some assumptions on the level of utilization of your productive capacity, which I think, I don't know if you, in your last presentation, Bruno, you are taking that into the alpha coefficient. So basically I would say if you take all the rate of profits that you observed from the data, then I think that you have to filter through this sort of average of profit rate through all the time, basically, because the equilibration process is a theoretical explanation, and you have to assume that the production, the capacity, the utilization of the capacity has to be more or less stable as well. Whereas, in reality, when you observe the rate of profit, you are taking into account whatever is going on at that point in time, which maybe you have an excess of demand because of some external reason. I don't know, maybe in 2010, chips demand increased because of, you know, the boom in computers, smartphones, and so on. So, you know, I think that's a phenomenon I think we have to take into account in this story.
I'm Saverio Fratini. I have a brief comment on Bruno's presentation. I'm not sure that this is really important for your argument, Bruno, but at the beginning, during your introduction, you talked about the idea that capital flows from sectors with a low rate of profit toward sectors with a high profit rate. So in my view, this idea presents two problems. The first is that this idea seems to assume that the stock of capital is a given magnitude. By contrast, according to Keynes, the theory investment, and in particular Keynes multiplier, tells us that you can invest in one sector without disinvesting elsewhere, because by the mechanism of multiplier, investment determines the corresponding amount of saving, so the corresponding amount of capital. The second problem is that this mechanism is, in my view, too much backward-looking. So you are implicitly assuming adaptive expectations. In my view, capitalists don't invest where the profit rate was high yesterday, but they would like to invest where they think that the profit rate will be high tomorrow. So again, we can use Keynes' theory of investment, and there are animal spirits from entrepreneurs which are not based on adaptive expectations.
No more questions?
Yeah, I just have a super naive question from someone who's like no clue what you're saying. But I felt like there's a disagreement between, like three of you kept insisting that we are seeing persistent competition and basically continuity, and then one of you was saying that in fact we are seeing an increase or a decrease in competition. So I was wondering if you could explain more what you mean by competition and how you think your data proves any of that, or what it proves or what it doesn't prove. Yeah, so just a very naive, very basic thing.
Hi, I'm Leo. I'm a PhD student in economics at UMass Amherst. I think I have somewhat of a clear idea of your arguments, and I think it's very exciting too. I'm also kind of a mathematician, so that's why I get attracted to these things. But I did want to bring up a debate that, for those who are acquainted with the dark web and Marxism, so this guy Michael Roberts partnered with Guglielmo Carchedi, and they had a debate with Macover and Paul Cockshott about how this probabilistic political economy, what relations or what implications it had for the whole question of the transformation of values to prices of production. And I think there, Macover, who I very much respect politically, tends to extrapolate this assumption of I think it's a simplifying assumption of the uniform rate of profit, to kind of say that the formation of the general rate of profit, it's irrelevant, kind of like a Steedman kind of view. And for me, I think Guglielmo Carchedi has he criticizes the concept of chaos that Macover is using, but I'm not going to get into that. But I think that the process of formation of the general rate of profit is the organic principle, and I think the maximum entropy method is kind of showing that. And the differentiation of the profit rates, in a way, shows the qualitative differentiation between different types of capital. In volume 3, when Marx talks about small-scale agriculture, he talks about small capitals that are basically regulated by the interest rate, which is what they need to survive. They just need to make a little bit more than that to be alive. And so between the rate of profit, which is typically higher, and the interest rate, you have this whole strata of capital, which are basically qualitatively differentiated by the scale that they produce with. And this has to do with rents and so on. But for instance, just to make my comment more concrete, I have a couple of friends who applied this analysis to the taxonomy of firms and used Minsky's taxonomy. So basically, if you look at the rate of profit of enterprise, which is basically the rate of profit plus the difference between the rate of profit and the rate of interest times their leverage, you can kind of classify what Minsky was talking about, the Ponzi scheme, the hedge funds, and so on. So I was wondering what you thought about this debate and how we can use these quantitative, more systemic probability theory to talk about qualitative differentiations, talk about how to, act politically on what we see in capital as a whole.
Anyone else? Okay. Who?
I have a question, and
Let me bring the mic. Just a sec.
I don't understand this, but maybe y'all do. When George Bush, he was 2000, 2008, I noticed that he lost. I mean, we lost, profit. And I'm not understanding. But that was like when he won in 2004, and they had some sort of meeting upstairs. Well, in 2014, the Wall Street Journal said, in Section C, it said, certain favored investors were called in and warned of the upcoming mortgage crisis. Now, I don't understand this. Do y'all?
Okay, so let's stop here because we have 5 more minutes. And, yeah. Okay.
Thanks for putting up with us. And with my voice again. Leo. One of the things that James is adamant about is that scientific inquiry needs to beware what he calls the mind projection fallacy, a failure to distinguish between the abstractions we construct in thought and the realities that those abstractions pertain to. Us Marxists are guilty of mind projection fallacy in a variety of different ways. One of the ways we are often is over the terrain of the relationship between market prices, systems of prices of production, and systems of value. And here, I don't think that colleagues are always duly diligent of the difference between 2 types of abstraction. We can have long period abstraction, which supposes along the lines of Smith and Marx, an idealized state where factors move competitively in a dynamic fashion in search of the highest possible yield, giving rise to a certain tendency to uniformity. That's one abstraction. The new interpretation is a different kind of abstraction, because I like to call it abstraction by systemic totality. Because what they say is, look, no matter what happens over a period of time, if we believe labor time is the source of value, and money value added is the monetary expression of it, divide one by the other and Bob's your uncle. Cool, but you're invoking a different thought exercise. We are invoking yet another one. The possibility of development of abstractions that would allow us to go from market prices to value systems predicated on the existence of statistical stability. And that's going to create new headaches. But at least coming from the Jamesian approach of things, we should be aware of these issues of abstraction, if I'm making any sense, and that should help things. Finally and quickly, to your answer, on mainstream, no successes yet, but really close, actually. This hasn't been as terrible as in other spaces, except for econometrica. It went out to referees, and the report was just astonishing. But in other high-ranking places, like, people get it, even if they're not interested, because they want to do more applied stuff. So we'll see. But it's worth it. If we can find little cracks, it'd be important. Ellis has many stories about that too. Thank you.
Okay. Well, we don't have too much time. Let me just say a few things on the first, Deborah, to respond to you. Yeah, the training for econometrics and applied. I think it's right in that students and economists, we want to do more applied work. We have a lot of data. What we might lack is the imagination on how to use that data for large-scale theorizing. So I'd say that modern econometrics tends to exemplify small-scale theorizing. Right? A lot of graduate students come in very interested in again, large-scale theorizing. How do we talk about capitalism? How do we talk about something at a system level? And what they're taught is to ask very particular questions about space and time and policy interventions. And they're, in fact, as I said, they're taught to do so first by abstracting away from social interactions and interdependencies, because these violate the domain in which typical causal econometrics are valid. So in political economy, and you see people appear to be ostensibly quite frustrated with those methods, but there's not much of an alternative. And I'd say that it requires a wholesale rethinking about not just the statistical methods. One, as I said, frequentist methods are based upon the logical fallacy that you can make any sort of inferential probabilities based on sampling probabilities. That's well known. Economists could do much better to look at the statistics literature, statisticians have called for an abandonment of the concept of statistical significance and the use of p-values. We continue to do that. We need to bring our statistical thinking up to date on the applied side, but the key here is that the applied side is intimately connected with the theoretical side. We like large-scale theorizing. We need, and this type of reasoning, statistical equilibrium, bringing a statistical methodology is very well aligned with large-scale theorizing empirically. I don't know about data on the South, but the thing is you don't need large data. You don't need any data at all. That's the beauty of Bayes' theorem. I mean, you have theory. You need data. Will start to discipline your theory. But you could have macroeconomic observations, and you can still, through the principle of Bayesian inference, to make inferences about the underlying process. You don't need to have a fully occupied frequency distribution. Those can be very useful for narrowing your inferences. But they're not necessary. And information theory turns out to be the most powerful method for dealing with underdetermined and ill-posed problems. When you only have a limited amount of information, how do you reason about the system? And we're just running out of time here. The other thing about Marshallian equilibrium and supply and demand equilibrium, these there often comes up is how do we talk about equilibrium processes? And usually with general equilibrium theory, and also based in Marshallian concepts of partial equilibrium, is that these usually theorize about a very particular contingent dynamic process to equilibrium. These are not robust notions of equilibrium. Classical political economy promoted a much more robust concept of equilibrium based upon things like strategic complementarities, which are independent of particular dynamic processes. When you look, what is now exemplified in things like supermodularity and game theory now, which is you have strong stabilizing feedbacks. You don't need, the Tatonement process is a very weak concept of equilibrium because it is based on very particular dynamics or a particular contingent process. But the concept of equilibrium in classical political economy is much more robust. It's independent of those particular paths that are traversed to equilibrium. And last thing to say about what does this prove about competition? Is competition changing? One of the important features about statistical equilibrium is it's not an equilibrium in the sense that this is a trans-historical phenomena. The system has a very strong tends to generate data with strong statistical signatures. These might be able to be ascertained by theory and held up to the data, which is certainly desirable. But moments are changing. We know capitalism is an evolving system. It's undergoing technological change. It's undergoing change due to class conflict. It's a historical system. And maybe competition in some ways changes due to changes in, say, laws and other regulatory structures and changes in institutions. But what's remarkable is that those don't seem to have any change on the overall statistical signature of these distributions, and that's where we find the connection to the generative dynamics, right? What are the most important institutions? Competition is one of the most organizing, strong institutions in capitalism, and that tends to give rise to these very strong statistical regularities. But moments of those distributions change, and there's nothing incompatible with statistical equilibrium thinking. They're not taking an idea from physics and applying it to an economic system. We're recognizing that these share similar problems. These are systems of many, many degrees of freedom, and these degrees of freedom are interacting in very non-trivial, non-additive, and complex ways. And we're trying to do rational inference based on limited information. And that's where the concept of entropy, informational entropy, comes in.
I know we have very little time, but just to clarify, because I got singled out about the competition thing. I think I tried to argue competition is as is. I think Bruno stated it very well. It's not there is a spectrum of perfect competition to monopoly. What I tried to argue is firms, at least in Europe, appear to be able to avoid the destructive effects of competition. But that's still competition. That's still decisions made by the firms. It's not that someone's outside coming and, hey, you can't sell, buy, you're going to stay where you are. Versus in the United States, they fight. But it's also competition. And I think Ellis summarized it well. Both actions are consistent with the idea of competition and the observed regularities, if that makes sense. I hope I made my point better.
Let's go to coffee break.